Hello everyone, welcome to this question. Let's have a quick go at this. So it goes here, the diagram shows the circle with the equation x squared plus y squared minus 6x plus 9y plus 19 equals 0. C is the center. Find the following. Says the coordinates for the center and the exact radius of the circle. Okay, so first of all, when you're doing something like this, we need to go back to this question and complete the square. So I'm just going to quickly go here and I'm going to put the x's together. So I've got minus 6x, and I've got the y's here, plus y squared plus 9y, and then you got the plus 19 equals 0. If I complete the square for this part, I'm going to get x minus 3 squared that. I'm going to get an extra minus 3 squared, so I need to take away that. Just take away 9, so I do this part, which is going to be y plus half 9 is 4.5. If I square that, I'm going to get extra 81 over 4, so I must take that away. And then plus 19 equals 0. If I get what I get now is x minus 3 squared, and I'll put this together here, y plus 9 over 2 squared. And now I'm going to just get my calculator. I'm going to just calculate these fractions. There we go. Should put this out before, so I'm just doing minus 9 minus 81 over 4, and then it's plus 19. And I'm going to get minus 41 over 4, which I'm going to throw on the other side, which is going to become a plus 41 over 4, and that represents my radius, and over here is my center. So my center, coming back to here, center C is going to be 3, x is 3, and y is minus 9 over 2. Good. That's my center. Okay, so that point there, you're going 3 along, and you're going to go here minus 4.5, 9 over 2. That's my center. And my radius, it wants the exact form, so I'm going to square root that. So the radius is going to be 41 square root over, always take the positive, and the square root of 4 is 2. Okay, so I'm just going to leave it like that. I want to see the exact form, so I'm going to leave it like that. That's a nice easy free marker there, job done. Then it goes here, the tangent to the circle at D meets the x-axis at this point, 55, 0, okay, and the y-axis at 0, minus 11. Okay, determine the area of the triangle OBD. OBD. So let me do that again. Determine the area of the triangle OBD. Okay, so before I start this, I know that here's the point D, and I know that this is, I know the center. So I really need to find, and before I do anything, I need to find the point D. Okay, and the way to find the point D is, first of all, I know how to work out the equation of this line here, which is a tangent to the circle, and I know that this is perpendicular to that. Okay, and I know the center point of here, which is 3 minus 9 over 2. So let's begin. So okay, let's do this in a different color. We'll start, just do it black, and I'm gonna line it up from here. We keep this one side just for the space. So let's have a go at this. So I'm going to first find the equation of this line. So that's going to be obviously it's going to be a plus. So it's the difference in y over difference in x. So if I went from here, go along there, so it's positive. So the gradient of that line, gradient of AB is going to be difference in y is going to be 11 over the difference in x is going to be 55 over 4. So if you did that, if you got 11 divided by 55 over 4, you'll get 4/5. Okay, so that's the gradient of this line, and because we know it goes through one of those points, we can choose any of those. We can just say, oh, I'm just going to choose that one. So the equation of AB is going to be y equals 4 over 5 x, and the intercept is minus 11. Just going to put a circle around that, so that's pretty straightforward, that one. Now because the gradient here is 4/5, the gradient of this line here, okay, is going to be the reciprocal of that. So just to write it here, the gradient of CD times the gradient of AB, because they're perpendicular, it's going to be -1. So therefore I know that the gradient of AB is 4 over 5, and I take it to the side, gradient of CD is going to be, take the 5 over by times in it, so that's going to be -5 over 4. Okay, so that's the gradient of this line, and I know it goes through this point, which is 3 minus 9 over 2. So if I put that in my equation now, where it's y minus y1 equals gradient times x minus x1, I'll get y minus becomes a plus, 9 over 2 is going to equal to, gradient is -5 over 4 x minus 3. Okay, that's there. And then if we rearrange that, you'll get the equation. I'm just going to do it in one go because I'm running out of space. Y equals, that expanded out will give me -5 over 4x, and that will be, if I do 5 over 4, multiply that by 3. Okay, so 5 over 4 multiplied by 3 is going to give me 15 over 4. And then I add, take away, because that becomes a subtract. Taking that to the side becomes a minus 9 over 2. I'll end up with -3/4. Okay, so that will be just slightly off there, going just below there. Now, so you got this equation of this line and the equation of this line, so you can easily find out the point D. So if y is equal to that and y is equal to that, then that equals that is going to give me where they intersect these two lines. So I now just put a box here, solve this, so that's going to give me -5 over 4x minus 3 over 4 going to equal 4 over 5x minus 11. So I'm taking that, becomes a plus on that side, take that, becomes a plus on that side, so I'll get plus 11. I'm going to get 41 over 4 on this side, and on this side, if I do 4 over 5, then I'm going to add 5 over 4, with 41 over 20 x. Okay, so yeah, so if I times 20 up and divide by 41, so they will cancel, and that will be 20 over 4, so therefore x will equal 5. Okay, so it's just 20. If I got that, yeah, so that's will be just x will equal 5. So we're going along 5, and I can plug that in anyone. I'm going to plug it in here because that's the fifth. So that implies y will equal 4 over 5 times 5 is going to be 4 minus 11, and y is going to give me minus 7. So the coordinates of D are going to be 5 along and minus 7. Now we've got that point, we've got this point, and got this is the origin, this point 0, 0. Can just simply draw this triangle because it wants determine the area of the triangle OBD. Okay, we know that's going to be perpendicular. Okay, do we know that? Just give me 1 second. No, it's not going to be perpendicular. Right, I'll take that back. This is not going to be perpendicular to that because this line that is perpendicular to C, it goes through at the circle, it goes through there. Okay, because we have that intercept. So not to worry about that. Not to worry about that. I'll just do it a different way. I'll get this length from here. Okay, and that will be the height going down from there to there. Okay, so if I redraw this triangle going like this, this will be O to B, which is 11, and this height here, which goes to that point D, will be 5. So just be careful. That nearly did it. I nearly fell for a trap. This is not a right angle. I should rub that off. Okay, because the tangent was a right angle and that had an intercept of -3/4. Okay, this is not, so we have to go approach it from this side here. I've drawn the orientation different, so it looks a bit clearer. That's 11, and that is straight height, which was the x-axis going to 5 there. Okay, along there, 5 up. So now it's straightforward. The area is just going to be 5 times 11 shared by 2, which will be 55 over 2. Okay, so it seems a bit of a long-winded rant. There's a lot of well, you got the circles, you got the equation of the straight line, you got the intersection, and then you got to go back and just be careful when you work in this area. And you can leave that as top heavy. If you want to half it, you can do. I'm quite happy for you to leave it just 55 over 2. Okay.